them right now.
No, I'm totally clean, Clay. Clay? Clay? Clay?
Hey folks, how we doing this evening? How we doing? We're gonna get started in about 2 minutes. Gonna give folks a little bit more time to get in here, but I'm looking forward to seeing y'all this evening for our unscheduled bonus stream. Yes, gonna be great. Awesome, hippie. Ready to get some homework done. Yeah, sounds good. Yeah, my cat says hello as well. He's excited. Doesn't know why, but he is. All right, good evening, folks. We'll go ahead and get started here right off the bat. Good to see some first timers here. Hi, Chris and Ikuzo and Yomiyu. Yeah, great to have you here with us this evening. We've been having a good time so far, so I'm glad you're able to join us. Oh, hello, Gentle Moonbell. Hi, good to see you. All right, I'm going to switch my screens here. Oh, yeah, hello. Yeah, no problem. I've been doing these for a little bit now and just recently moved to Twitch. And yeah, it's been going great so far. All right, so I'm going to switch to my screen here. Okie doke. So now you should see my CodePen window, and I've made a few settings changes, so y'all can let me know what you think. Based on some suggestions from the wonderful intelligence, I was able to tweak my CodePen settings just a little bit to switch to high contrast mode, which should make the stuff that's commented out a little bit brighter on the screen, because they, suggested that, well, the code that's commented out might look a little bit dark on the VOD. So I hope this looks okay. Guys, you can let me know your feedback and how it looks. Yeah, you can go in your settings. You can tweak a lot of the things. Actually, you can tweak behavior, the editor, and if you want to change colors and like your, from light mode to dark mode or vice versa, you can go to the global editor settings, and there's a ton of stuff you can tweak there. You can even have like key bindings for like Vim and stuff like that if you want to get crazy. But yeah, it's pretty neat, and you can change the font. I did adjust the font as well. So we're using a slightly different font that looks to me to be slightly clearer. So again, any feedback that you guys have, positive or negative, is great. Yeah, and set the behavior to not run until I tell it to. Yep. Actually, yeah, that's what we have going on here too. Just especially since we're working in JavaScript, if you leave it default, the console will try to show you results while you're typing, and that's just not fun for anyone. So, yeah. And hey, Noi, yeah, great to have you here. Is the font big enough? In the past, I've changed the size by zooming in, but I did find that there is a setting I can change to actually change the font size rather than zooming in, which gives us more real estate to work with. So can you guys read this? Do I need to still zoom in a little bit? Okay, thanks, Rascal. Good. Oh, hey, Dope Antelope. Yep, readable. Okay. Well, if anybody has, as we're going, if anybody has trouble reading it, oh, could it be bigger? Yes, we can make it bigger. Let me zoom in a little bit. How's that, Akuzo? Is that okay? I can probably go one more notch if we need to. Perf. Okay, awesome. Hey, Mirabek, how we doing? All right, so we got a good amount of people in here, so I think we're going to go ahead and get started. I'm sure more folks will pop in as we go. And two, also, as I've said before, these VODs are being recorded automatically. So if you have to leave early, or for the folks that come in late, the full VOD of my entire stream will be available on my channel, just right there on the homepage, along with the other couple streams that I have done on Twitch. My previous streams prior to moving to Twitch are available in threads on the Discord in either House Hamilton or Women in Tech. They're just pinned. They're not pinned. They're just threads that are available at the top of the channel, and you should be able to find them there. So all of my content should be available. Will you be doing one for next week's array readings? They're brutal. Yeah, I'm planning to keep streaming. If you look on my channel, I've got my schedule there. I've generally been streaming on Wednesday evenings or Sunday evenings. Oh, hey, Caitlin. Good to see you. Hi. Yeah, great to have you here. But yeah, I'm going to be streaming on Wednesdays and Sundays, and what we cover, just really depends on, whether I have a cool project I want to show or if we want to review homework. Sometimes I'll have polls on my Twitter. So if you're not following me on Twitter, please do follow me, because I might post a poll asking what we should cover in the next stream, and whatever wins is what we'll do. So if you want your voice to be heard, yeah, go ahead and vote there on Twitter. Yeah. Okay, awesome. Thanks for following. Yeah. Okay, so yeah, let's go ahead and get started, as long as all the settings are good. And as always, feel free to stop me at any point with questions. And I've got the chat going here on my other screen, so I can see if y'all ask questions or have comments, or if I've done something wrong, feel free to correct me. But yeah, let's get into it. So the Eloquent JavaScript, I found it really interesting so far. I actually haven't done this week's reading yet in Eloquent JS. But yeah, it's definitely a little bit of a step above maybe some of the readings that we've done so far. And that's not a bad thing. It's just we continue to sort of iterate on the concepts. And I really like that we just, keep rereading the similar concepts over and over again, but get slightly different takes and slightly different approaches. Oh, great, Hippie. Yeah. You're ahead of me. But yeah, so there are problems at the end of each chapter, and the problems themselves, they don't maybe hold your hand quite as much as some of the other problems that we've done. And I really like these. They remind me almost of Code Wars challenges, in that they don't really give you a ton of context. You just kind of got to figure out the best way to do it. So like with everything, any approaches that I demonstrate here are my own, and they're not necessarily the right way, so to speak. There's not one right way, right? And they may not even be the best way. There's ways we can streamline this stuff. And so these are just possible approaches that you can kind of use to find your own way of doing it that works best for you and that makes sense for you. But yeah, all disclaimers aside, let's go ahead and dive in and start taking a look at the questions. So in chapter 2, the first question reads, looping a triangle. So we're supposed to write a loop that makes 7 calls to console.log to output the following triangle. Yeah, so they give us a demonstration of what our output's supposed to look like. And it's essentially just basically a pyramid of hashtags, right? And what we can see here is that in each one, right, we're adding essentially one additional hashtag per line. So what it looks like here is that we start with 1, right? And then we're just continuously adding 1 per line, right? We don't have to rebuild the string every single time. We can start with a string of essentially 1, right? And then just keep adding 1 to the existing string each time. Now, if we're repeating an action over and over again for a set amount of times, what do you guys think we should use to accomplish this task? Or what could we use? You don't have to give me an exact answer, but just a general, what concept should we apply? Yeah. Yep. A loop, a for loop. Yes, exactly. Yep. Yeah, so this, in order for us to accomplish this, the probably the most straightforward way would be using a loop. Yep, everybody's got the right answer. Yeah, awesome. So essentially, this is going to be a pretty short loop, and we could use a for loop. Now, another possibility might be a while loop as well, and for this particular case, if we actually use a while loop, we can make this thing fairly compact. It doesn't take us very many lines to write it, but using a while loop. And because I like to live dangerously, I'm going to write it with a while loop. But obviously a for loop would be valid as well. Because I like to put myself in, have the opportunity for infinite loops. I tend to use while loops fairly often, actually. But that's just me. All right, so let's start out with just defining a string defining a variable with a string inside of it. So we're just defining a variable. I'm calling it tag, and I'm just starting it out with just one hashtag in it, or one octothorpe. I'm going to call it a hashtag. I know it's an octothorpe, but octothorpe is hard to say, so hashtag it is. And I'm going to use a while loop here, and I'm going to say while. Now, we know of what's a possible way that we could use, that we could figure out the length of a given string. Does anybody know what we could use to figure out the length of a given string? So for example, we want this triangle to stop right after we hit 7 hashtags in a row. So we don't want to go beyond that. So what's a possible way we could use to figure out the length of a string? Just to check. Every time we loop, we want to check the length. Yeah. Yep, you got it, Mohammed and Dope Antelope. Yeah. We're going to say length. Yeah. Hey, Tall, Dark, and Coding. Yep. Yeah, so that the less than or equal to, yes, that is the symbol we're going to use to tell us the relationship, between our, to tell us, what kind of relationship we want. But we do need something that's going to grab the length of the string each time we loop around. So, yep, you guys are all right. You guys have got it. We're going to say tag dot length, and then we're going to say, yep, just like Yomu said, we're going to say less than or equal to 7. So while that length is less than or equal to 7, essentially we're gonna loop back around, and we're gonna add an additional tag to the string. So since we started our variable with one hashtag already in it, the first thing we're gonna do is we're gonna console log that, log tag. So the first time this goes around, it's gonna start, and it's gonna immediately console log, the first one to build our first row, right? And then the next thing we're going to do is we're going to essentially add another tag onto our existing string, right? And so what would be the most efficient way for us to do that? Tag plus plus, that's an option. Template literal, tag plus equal tag. Yeah. These are all options. So let's try. Let's try tag plus plus first. Concatenation. Yep, yep. And that's essentially the action that we're doing. Yep, we are concatenating. Yeah. So let's do. Let's try that first. Okay. So tag plus plus. Now let me. Might be playing with fire here, but we'll try it. Yeah. Okay. So that didn't work. Now, why did that not work? Anybody know? Why can't we do tag plus plus? Yeah. So it's as far as I know, the using this shorthand, this tag plus plus is arithmetic, and since we're dealing with a string, I don't think that's going to work for us. But what we could do instead is we can still do yep, Rascal, yep, said it more concisely than I did. Plus plus is for numbers, and so if we were, you're on the right track. If our tag value was like a 1, right? And we just were saying like tag less than or equal to 7, if we weren't dealing with a string, then yeah, we could absolutely use this iterator here. And that's what we would normally do if we were looping through, a variable with numbers, right? But in this case, and that's why I asked, because this case is kind of unique in that we have a tag that is not a number, it's a string. And so that's why we had to use tag.length here instead of just tag. So somebody nailed it earlier. We're just going to use, essentially, we could say tag plus equal tag, or we could just do, tag plus equal hashtag. We could just add another one onto it here like this. Yeah, and so, yep, yeah, you got it. So what this is going to do now is it's going to essentially do tag plus hash, right? Except just we have the shorthand. This particular shorthand does work because we are specifying what we want to add to it. So let's run this again. We're going to clear. Yeah. Yay, there we go. Yep. So now we get our little pyramid, right? So we can see that it looped through, and each time it did, it console logged first, and then it added one onto our existing string. Yeah. And as Rascal stated, yeah, the plus plus attempts to coerce the non-number to a number. So, yeah, that would work if there was a number in the string. So like if we had a string that was like 1 with quotes around it, then it could coerce it. But here it can't. Yep. Awesome sauce. So yeah, this was a fun exercise. I like it because it, I think previously all the looping exercises we've done have really been with numbers as far as I'm aware. And this is telling us that we can loop other things as well, and that's still valid. The example doesn't have quote marks. Well, I think if I were to do this in the regular console, like in Chrome, I don't think it would have the quote marks. I could be wrong there, though. Somebody can try it. Oh, yeah. Yeah, what's your question, Mohammed? Go ahead. Yeah, CodePen adds some weird stuff. Yeah, that's what I thought. How is the loop counter being incremented, please? Yeah, that's a good question. Okay, so let's walk through this, all right? So we declared our tag first with just one character in it, right? We just have the hashtag, okay? So this is saying while tag.length is less than 7, okay? So on the first loop, Mohammed, what is our tag.length? Just the first time around. Yeah, 1, right? Okay, so we console log that. And then in the last part, we're adding an additional tag to our existing tag variable. Okay, so we loop around again, right? And so at the start of the second loop, what's our tag.length? 2. Yeah, so you can see that's how it's being incremented, right? Because we have this tag.length as our comparison of our comparison value against 7. So each time we loop, that's going to grow by 1, right? And so then, we're going to hit 7, which is our last row. We'll add an additional tag. It's going to try to loop back around. It's going to see that tag.length, at the very end, it's going to see that tag.length now has a length of 8. It's going to say nope, and it's going to kick us out of the while loop, and we're done. Yeah. So, and that's why I really like this question, like I was saying, because it makes you think outside the box a little bit with how you can iterate things other than strict numbers. Yeah, yep, because we have that tag.length there. If we didn't have this, if we weren't incrementing this, then it would absolutely be an infinite loop and we'd be in trouble. But yeah, it since we do have something that we are incrementing and then we're feeding that into our while statement, it still works. Yeah, good question. Okay, any other questions on this before we go to the next one? I'm going to take a drink. Gotta hydrate. All right. Good deal. Okay. And thanks, folks, for confirming that there's no quotes in Chrome and that I'm not out of my mind there. I was thinking that Chrome is maybe a little cleaner in that formatting than CodePen, but yeah. Okay, so next one. Next question is chessboard. Says, what? Oh, no, that's no problem. I know the first time I saw those quotes when I ran this, I was like, that doesn't look very good. Yeah, no, it's just a funky formatting thing that CodePen does, and maybe somewhere buried in the editor there's a way to modify that. I haven't looked. Yeah, so chessboard. So yeah, this one's really interesting too. I really like these Eloquent JavaScript questions because they really bend your brain a little bit. So chessboard, write a program that creates a string that represents an 8x8 grid using new line characters to separate lines. At each position of the grid, there's either a space or a hashtag character. The characters should form a chessboard. Passing the string to console.log should show something like this. And so we can see we have 1, 2, 3, 4, 5, 6, 7, 8 rows of hashtags, but they each have like a space between them. If I highlight that, you can kind of see how there's spaces in between them. And if you notice, the first row starts with a space, right? The second row starts with a hashtag. Third row starts with a space. So it alternates. So we can't just do like the same print, we can't just like console log the same pattern 8 times, right? We can't do like we did in the first one and just maybe just do 8 console logs of the same pattern. It actually alternates. Yeah. And so this one actually really bent my brain, too. And so I had to look at the hints. There's actually, after each question, if you hadn't noticed, and sorry for the white screen there. I hope I didn't burn your eyeballs out. There is actually a hint button somewhere. And I already clicked the hint on this one. You can click the hint, and I actually had to use the hint for this one, just to figure out how to even start. Oops, sorry. And two, so the hint essentially advises that you can tell your program what value to print, whether it's a space or a hashtag, depending on whether the intersection of the row and column is even or odd. And I'll show you guys what I mean. I think it's easier if I put this into another medium here. Izuko says, could we create a string that prints out, essentially, I think you're saying print out 4 hashtags and alternate the index that we start with. Yes, but we don't even have to do that. We can be a little bit more dry in our code even. So if I put this into Excel because I think it's easier to see, and I can zoom this in if you guys need it. Let me zoom in a little. Come on, zoom in. So here's essentially the grid that we're trying to print, right? We start with a space, we do a hashtag, space, hashtag, space, hashtag, space, hashtag, right? And then the second row is the opposite, right? So if we look at where we start at essentially column 1, row 1, right? Then we go column 2, row 2. Column 2, row 1, column 3, row 1, column 4, row 1. And if we add together the intersection of row and column, we get 1 plus 1 is 2, and that's an even number. So we have an even, right? And then if we add together column 2 plus row 1, we get an odd. And 3 plus 1 is even. And so we can see that we get an alternating pattern here, right? Odd, even, odd, even, odd. And now if we go to the second row, we add together column 1 plus row 2, and we get odd. So you can see that like as the book suggests, the intersections of the rows and columns alternate whether each square is even or odd. And so we can use that to basically populate the grid for us with either hashtags or spaces, depending on whether these values are even or odd. And so that, well, I mean, it's not necessarily a better way. I would say it's just maybe a little bit more compact. And like I said, I didn't come up with this myself. If you look at the hint in the book, it basically, this is what it tells you to do. And it says, just use the modulus and determine whether the intersection of the row and column is even or odd, by just using modulus 2, like we've done a bunch of times before. And I think that's a really cool solution for it. And now, but how do we, so that gives us how to tell what type of symbol goes into a square. But we're also going to need to know, essentially, we're going to need to be able to tell our program when it has filled up a row and it needs to go to the next one, right? Because it needs to know when to stop. Because otherwise it's just going to, we're just going to print space hashtag for, forever, right? So we need to know when to stop, when to go to the next row, and also when to stop printing rows. So we need to know when to stop printing our column. For each column, we need to know when to stop. And then we need to know when we have hit the last row. Okay? You were using modulus 2 to figure out the row, but not for specific squares. Yeah. I mean, that's a good start, definitely. And you could probably essentially have like 2 string types. One, kind of like Ikuzo was saying, you could have 2 string types. One that starts with the hashtag like this, and one that starts with the space, and then maybe use modulus to figure out which one you should print. You could do that too. That's a possible option. In this case, though, how can we tell our program essentially when to stop printing a row and go to the next one? And how can we tell it when to stop printing, how can we tell it when to stop printing columns? How can we tell it when to stop printing columns and go to the next row? And then how can we tell it to stop printing rows? Do we have any ideas? How do we build some containers to tell it when to stop? And you're welcome to look at the Eloquent JavaScript hint too if you want to look at it. Yes, less than 8. Yep, you're on the right track. I see an I, I see a less than 8. Yep. What do we need to put that inside of in order to make it keep printing until we tell it to stop? Yeah, I know it's a tough question. A loop. Yes. Yep. We need a loop, right? Loops. You're on the right track. Inner loop. So we'll have an inner loop. And what do we need around that inner loop? Good guesses. Because let's think about what we're going to do, right? We want it to essentially... No, that's okay. I know this is a hard thing to get your head around. And you're welcome to also look at the Eloquent JavaScript hint too, because it kind of tells you what to do there. So, yeah, another loop. So we're going to have, essentially what we're going to do is we're going to have one loop. We're going to have two loops. We're going to have one loop that's going to tell us to print 1, 2, 3, 4, 5, 6, 7, 8 times. And then it's going to tell us to go to use a new line character essentially and go to the, to go to the next line. And it's going to tell us to print another 8 times, right? So we could do that, we can do that no problem. We know how to tell it, we know how to tell a program to print something X number of times and then log that and then go to the next line, right? We did that in the first question. Where we had it print a hashtag and then another 2 hashtags and another 3. And, we know how to do that. But we also need to know how to tell it when to stop printing rows as well. So we know how to tell it when to stop printing columns, but we also need to tell it when to stop printing rows. So in order to do that, we need nested loops. One for the columns and one for the rows. Okay, so let me put this back here. And this is going to be a bit wild, but I'm just going to kind of start doing it, and then we can review exactly how it's working, and hopefully that'll make more sense. Okay. And 2, I'm going to, this question has 2 parts technically, where it says, write the program first, then define, make it so the size can be flexible. I'm just going to write it with a flexible size, just because all it is, it's just a variable telling us what the size is versus hard coding it. So I prefer to use variables anyway. So that's what I'm going to do. So we're going to have we're going to have 2 nested loops, one for the rows and one for the columns. So we're just going to say we're going to declare a variable for the size, which is going to tell us, we're just going to set it to 8 because that's what it tells us we need to have. Each row is going to have 8 characters across. So 1, 2, 3, 4, 5, 6, 7, 8, right? And then we're going to have 8 rows in total, okay? So we're going to declare a variable for our size, and we're going to say let board equal an empty string just for now. This is what's going to hold our total board when we're all done and we're ready to console log it. That's just an empty variable for our board. Oh, Mohammed, you got disconnected? Okay, well, we're still getting started here, so good. Okay. So let's declare a for loop first, and this is just going to basically print the number of rows that we want to print. So if we go back up to the first question, this is basically going to be what we did for the first question. We basically just said keep printing a new row while a certain criteria was met. So just print rows until we've reached the appropriate length, right? And that's essentially what we're just going to do here. So we're going to say, I'm going to be real specific here. I'm going to say let row equals 0. We're going to start that at 0. And then while the row is less than the number of rows that we've specified, so while row is less than size, then keep going, right? So essentially this for loop is just going to say, hey, have we reached the number of rows that we said we wanted to have yet? No? Okay, keep going. That's all that's doing. And now we're going to get a little wild here because we're going to put another for loop inside, okay? And this for loop is going to print our columns. So we're going to say this is what's going to tell us how long our column, how many columns we need to print inside each row. So let column equals 0. While column is less than size, increment the columns. Okay. Okay, there we go. Okay, so there was a question, why is row and column 0 and not 1? Actually, that is a good question, but I think I think this still works. And that's true. That's not what I put in my little Excel diagram here. I did start at 1, so yeah, I know this is it is. It's a mind bender. So yeah, I think if we start at 1, I don't think that's going to hurt anything. And I probably, just to make it look more like my little Excel diagram, I think we can do that. I believe that if you start at 0, it's still going to work, because if you take the modulus of row and the remainder of row and column divided by 2, is that still going to be actually equal to 0, or is that going to be infinity? I don't know. Good question. It still seemed to work for me, but we'll start it at 1 just because it matches the little Excel diagram. Okay, so now essentially what we're saying here is infinity. Interesting. It still worked for me, even though yeah. Well, anyway, we'll do it at 1. So inside of our for loops here, now we're essentially going to do what I said originally, is that we're going to, in order to figure out what character to print, we're going to take the intersection of the row and column, right? We're going to add them together and divide them by 2 to see if they are even or odd. And for all of the even intersections, we're going to print a space. And for the odd intersections, we're going to print a hashtag. Okay? So if row plus column has a remainder of 2, or sorry, yeah, has a remainder, when divided by 2, has a remainder of 0. So modulus 2 equals 0. So essentially all we're saying is, if you add the intersection of the row and column together and divide them by 2, is the remainder 0? Are they even? Oh, yes, and that's a good point. Mohammed says, yeah, if I'm increasing the starter counter to 1, I'm going to need it to be less than or equal to size. Yeah, good catch. Yep. Okay, so if it's even, then we want to print a space. So we're going to say board plus equal space. Okay, and then else, if it's odd, then we're going to print a hashtag. So board plus equal hashtag. Okay, now let's look at where this loop starts and ends. So this inner for loop is counting up from, essentially what it's doing is it's counting across from here. I don't know if you guys can see my little highlight there. It's counting across from here all the way from 1 to 8, right? And then when we hit the end, we want to go to a new line. We don't want these strings to keep printing next to each other. We want to go to the next line and start printing there. So in order to do that, we need to tell our program to put in a new line. So at the end of my loop, once this loop rolls through, then I need to basically tell the board to add a new line character. So board plus equals new line, which is this /n. And the Eloquent JavaScript text gives you this symbol so you know what to add. But essentially this says, hey, just start logging a new line, please. And then continue after that. So what we've done is we've gone across our first row, determined which characters to print, and we've ended the loop, and we've appended our code with a new line character. So it's going to go to the next line and be ready to print. Now we break out of the inner loop, which ended here. We've broken out of the inner loop and we go into the outer loop. Okay. And we say, okay, row is now 2, right? Because we went into the loop originally. Row was equal to 1. We ran through this inner loop 8 times. It finished, added a new line. Now we start over again. Now row is equal to 2. And we start this inner for loop all over again, and we start printing the second line. So we start, now we're going across this second line. Okay, and so as we're going across the second line, now, again, column starts at 1 and loops through 8 times, and we determine which character to print at each intersection, whether it's a space or a hashtag. After 8 times, this loop ends, and then we add another new line character, and we go back up to the beginning. So essentially what we're doing is we're printing all of the characters in each column, finishing that loop completely, adding a new line character, and then going to the next row, doing the whole thing again, and doing all of that 8 times. So we're printing the whole board dynamically in that way. Now I know this is a lot, so let's just run it and let's see how it goes. Okay, let's see. I think, did I comment out my previous thing? No, I didn't. I always forget to, as you guys watch my streams, you'll know I forget to comment out my previous work all the time. Okay. Oh, and you know what didn't I do? Why didn't that output anything? This is an easy one. What did I forget? Yeah. Yep. I essentially, and you're not wrong, Ray Anthony. We didn't write a function here, but I didn't call it because I didn't console log my output. So console log, yeah, you're not wrong though, because that's still basically a call. We're basically just calling our variable here to print it. So once we're done, then after all of our loops have finished, after both of our loops have finished, we just put a console log and log everything that we've added to our board variable. Yeah, yep, you're right. Okay, so now let's do that again. Yeah, look at that. Now the quote marks make it look a little bit off. But if you take away that quote mark, it would be lined up really nicely. You can see that the last row is lined up better. Thanks, Rascal. Yeah, that's how. If you want to turn on the manual run button, Rascal's provided the instructions on how to do it there. How do we get rid of it? I don't know. That may be a setting you can turn off. I don't know what it is. If anybody does find it, feel free to share. Like I say, if you're working in the regular console, you're not going to have that problem. It's just a weird thing about CodePen. It likes to really make sure that you've got a string, I guess. But yeah, so this worked. It printed the grid in exactly the way we expected. And basically what it did is it ran that inner loop, right? It went into the for loop for the first row. Row is 1. And then it went into the inner loop in here and it printed across 1, 2, 3, 4, 5, 6, 7, 8, right? And it did the comparison for each intersection to say, hey, should I print a space or a hashtag? And then once it went through 8 loops here in the inner loop, once column was equal to 8, then it printed a new line character and went back to the outer loop. And so this is a really cool way to print like a grid. And you can use this if you're trying to, if you're trying to print something to the DOM and you're trying to print something in a repetitive way, for example, like a whole lot of buttons, think of like a calculator or something like that. If you want to just print a lot of buttons really quickly, you can actually use this to do that. And if you're going to tune in on Sunday, we're going to be building a Wordle game. And we're going to actually use this very same methodology to print our Wordle game with, essentially print like the boxes where you type in the letters. We can use nested loops in order to just really quickly print the game board. Mine is printing out 3 in one row and 4 in another. Interesting. Yeah. Not quite sure what might be happening there. You just want to make sure that both of your loops are kind of like identical in their starting counter, and that you have, row less than or equal to if you're starting at 1, or just less than if you're starting at 0. You might want to check that and make sure that, you have increments on both, and that you're doing the modulus comparison of each intersection. Yeah, okay, yeah, there it is. Yep, that'll do it. Yeah, so I know this one is a little bit to wrap your head around, but if you kind of just think about it, you can almost think about it almost like a typewriter, right? If you ever used a typewriter, you print across one row, ding 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 ding, and then at the very end you hit the return key and the carriage goes chunk and goes back to the beginning and starts printing the other row. So that's how our loops work together, right? We print everything inside first, and then the big loop kicks in and kicks us back to the beginning, and we print again, and we loop back again and print everything again. Yeah. Oh, hey, Jumpo. Yeah. Welcome. Yeah, you can always catch the beginning on the VOD later on if you want. Yeah, good to have you. Yeah, so what questions do we have on this? Do you want me to go through it again? Do you want to try it? We can also adjust the size and make this larger or smaller. So if we run this, we put size 10, we're going to end up with essentially a 10 by 10 grid instead. And I forgot to clear the console the first time, but you can see it printed down below there. Good. Okay. And Yamiya, does that mean you have a question, or you're okay? Oh, good. Okay. Great. Awesome. Okay. Yeah, this is kind of wild, but it's really cool what it can do, and I think this is going to be especially cool once we get to more of like the practical applications in the DOM of using JavaScript. Like I said, how you can basically automate some of the tedious formatting stuff and like the Flexbox stuff that you had to do, like making a gallery, for example. If you want to make a gallery with a bunch of photos, like fill the whole page with photos, it's a lot easier if you can just have your JavaScript essentially auto-generate it for you, right? Would it be possible to not create the variable size, but rather just write 8? Yes, yeah, you could. And I think that, that's what the question asks at the start. It says, hey, just do a thing that represents an 8 by 8 grid. So essentially it just wants you to hard code it. The second part of the question said make that into a variable, which I skipped the first part and just said I just want to make it a variable right from the get-go, because I don't like, if I can avoid hard coding something, I want to. If I can make it a variable, I will. So in that case, we just made it a variable. But yep, totally an option. Yeah, it makes it more dynamic. Yep, that's exactly the word. You're making your code more dynamic by making it a variable. And 2, hard coding stuff can get dangerous. If someone's coming back and trying to troubleshoot your code later, if you have a bunch of hard-coded stuff everywhere, that's going to make it really hard to do updates. But if you're using a variable, then you only have to change the value in one place, and it's going to be changed across the board. So that's why variables are generally good. And variables that have descriptive names are even better. Don't name your variables A, B, C, and 1, 2, 3. Don't. Well, I guess JavaScript doesn't allow that, but don't name your variables A, B, C. That's bad. Okay, so we're going to go ahead and move on unless anybody has any other questions. And feel free, go back, write this out yourself, mess with the values, and see what happens. Run it a few times and try to get a real feel for what's happening. And two, maybe just try writing the inner loop. Just try writing this loop first. If you're still not quite getting it, try writing the inner loop first, just this part. See what that does, right? And then add the outer loop around it and see how that changes the behavior. So yeah, maybe think about that if you're still not quite following what's happening here. Okay, next question. The previous chapter introduced the standard function math.min that returns its smallest argument. So you can put in multiple numbers and it's going to spit back the minimum of those numbers. We can build something like that now. Write a function min that takes 2 arguments and returns their minimum. So we've done something like this before, I think, but I think we did it in our last stream. I think it was a question in the JS way as well. And so when you see these questions repeated like this, maybe something you want to think about, oh, hey, this could be a question on a job interview someday. I might want to know how to do this. I might want to know an efficient way to do this maybe. So let's if you remember what we did, I think in the last stream, I think we did it just with a standard if-else statement. But let's think about maybe what could be the most efficient way to do this. So essentially, we're going to write a function. We're just going to say function min num1 num2, and I'm using standard declaration here just because I don't really want to use an arrow function for this. Essentially, all we're doing is we're saying let's say if num1 is less than num2, we want to return num1, else we want to return num2. And if num1 and num2 are equal, it doesn't matter which number we return, right? Because they're equal, they're the same. The user's not going to know the difference. So the only thing that really matters is that if num1 is less than num2, then we return num1. And if that's not true, then we should return num2, because that means that num2 is greater than num1. So what's a really simple, efficient, one-line way that we could write that statement? You don't have to give me the exact statement. Just give me your thoughts. Any ideas? In this case, no, because we're doing a comparison, right? We're not trying to say, we're not trying to iterate through anything, right? Well, return math min, yes, but in this case, we're not allowed to. Well, in this case, I mean, we could use math min, right? There's nothing preventing us, but let's challenge ourselves a little bit and let's pretend that math min doesn't exist. So let's write something that works like math min does, but maybe oh yeah, there we go. Muhammad's got it. Let's use a ternary operator. And for those of you who aren't familiar, if else, and that would work too. We could say if blah de blah, right? If else, that's totally valid. But let's try and see if we can use a ternary operator. And for those of you who aren't familiar, a ternary operator is very similar to an if-else statement, except it puts everything on one line. So we're going to say return, because we want to return something to the console. And we're going to do our comparison. So we're just going to say num1, if num1 is less than num2, which, I mean, that's what we would say in an if statement anyway, right? Yeah, and got some real, yeah, I got some real ways to streamline that there. So we'll do that. We'll try your suggestions, Chris. We're gonna write our ternary operator a little bit more longhand first, just so we can fully understand what it's doing. And so, but yeah, then we'll try those other suggestions too. So we're gonna do our comparison. We're gonna say, is num1 less than num2? Question mark. If that's true, then we return num1. Else, in all other cases, we return num2, right? So that's what we just talked about. So what is this doing? It's doing the comparison, num1 less than num2, literally asking the question, is that true or not? And if it is true, we return num1, else, with the colon, we return num2. And that's a ternary operator. It's just a really nice one-line way to write a simple if-else statement without having to say if, operation, bracket, else, bracket, 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 all that. So let's try it. Let's see if it works. I'm going to comment out my previous code here. Let's try it. Yep, so you see it worked. So the first console log was supposed to return 0, and it did. And the second console log was supposed to return -10, and it did. Yeah. So any questions on what we did here for this ternary operator? And like I say, you don't have to use these. You could use a standard if-else. There's nothing wrong with that. It's really, like I say, it's whatever you can figure out how to use and understand. And in this case, this is nice because it fits on one line. But may I ask which one is more efficient? Well, it depends on what you mean by efficient. So efficient for you to read would probably be the ternary operator because it's a single line and you can just scan across it really quickly. An if-else statement is going to take a little bit longer. Mohammed, in this case, it doesn't really matter because let's think about it. If num1 is equal to num2, it doesn't matter which one we return, right? So we could use this or this. It doesn't make any difference either way. We don't have to test for equal, Mohammed, because think about, okay, what happened if I passed in 10 and 10 for this, right? It doesn't matter which one we return. So in this case, this statement here, if we pass in 10 and 10, this statement is going to evaluate to the else, right? It's going to return num2, but it doesn't matter because they're the same number. So we don't have to test for equal. We could, but we don't have to. Yeah, let's run it. Let's run it. There's no harm in that. Yeah, see, it returns. It returns 10, which is exactly because condition is false. Yeah. Oh, thanks, Cool Pants. Yeah, the differences in efficiency is negligible. Yeah, and thanks for answering that. Best to use what is easier to read and consistent with the code base. Yes, good answer. With the small projects as we're working on, and in most cases, even the larger projects that you might work on, unless you're doing some really crazy stuff, do what works for you and also what is compliant with whatever your company or employer recommends. Your employer is probably going to have standards on whether you're allowed to use ternary operators or not, or whether they want you to use, standard if else or whatever. So yeah, do what works for you either way. If you were writing it with if else, return would be on the last line, right? Well, let's write it with if else. That's fine. We can do that too. I'm going to copy my syntax here. So function min is going to be the same. And we would say if num1 less than num2, then we would say return num1, and then else return num2, essentially. Yeah. Oh, you got it, Mohammed. Okay, good. Good, good. Yeah, so I mean, there's nothing wrong with this. And if this makes if this is what you're able to follow, then absolutely use this. It's okay. For the kind of stuff we're doing right now, don't worry about like, milliseconds of efficiency or anything like that. Do what you understand right now, whether it's this or this. Or even if you want to write out, like even if you want, you could turn this into an else if and make it even more explicit and very clear. You could say num1 greater than, or well, sorry, num1 greater than or equal to num2. You could be super clear about that. Even though that's not necessary, you could absolutely write that too. Oh, thanks, gentlemen. Yeah. See you next time. And you can catch the VOD later on, so you won't miss anything. You're all good. Oh, no problem, Mohammed. You're fine. I can understand you just fine. And Cool Pants, you personally try to avoid nested ternaries as they can get out of hand very quickly. Yeah, when you're starting to nest things, I think ternaries are best. Ternary operators like this are best for just like, simpler statements. When you just kind of want a shorthand an if statement really quickly. If you're doing nesting, I agree. I would suggest, just use the standard if else statement, and that way it's easier to read, more clear. But yeah, if you have a simple one like this, just bash it out in one line like this, right? Or no else at all with the first return. Yep. Yeah, you're exactly right, Cool Pants. It just depends on how explicit you want to be and how, you're depending on your level of comfort with if statements. Yeah. So I'm going to get rid of this guy for now. I'll leave this in the code pen. You can come, like I say, I'm going to share this code pen with y'all. This will have both the JS Way exercises and the Eloquent JS exercises in it. So you can look at these and, try my answers or make your own answers and see if they work the same. So I'm going to leave this one in there. Yeah. Okay, so this works. Any other questions here? Yeah, Cool Pants, you're exactly right. And that's what I keep restating too, is that my answers aren't quote unquote the right answers, right? There is no right answer. There's a bunch of different ways to do it. And a lot of times, I'll be doing a code wars or something and I'll think I've come up with some sort of slick solution, and then I submit it and I see somebody that's done it, in one line, right? Using all sorts of crazy stuff. But that's not a solution that makes sense to me or necessarily vibes with the way I do things. So I might not use that. But it's all about just feeling out what works for you. Yeah, lol, been there, done that. Absolutely. Yep. When people start using a bunch of regular expressions and stuff like that, I have to tap out. I'm not there yet. Yeah, regex is beyond my skill level at this moment. Yeah. Okay, so we'll comment this guy out unless there's any more questions on this question. Move on to the next one. And you guys may or may not have noticed too, I did skip a question in chapter 2. There was a FizzBuzz question and I skipped that one. And that was on purpose, just because we've now done FizzBuzz. Leon's done it in class, and I've also done it on my very first Twitch stream as well. So I feel like we've covered that one kind of to death and seen a bunch of different ways to do it. So, oh, you got FizzBuzz. Awesome. Cool. Yeah, because Leon has done it. I've done it. So you can always look back at either of those solutions if you would like. Don't want to keep rehashing the same thing. So good. Okay. Awesome. Okay. So next question. No free space. FizzBuzz clicking was a breakthrough. Good. Yeah. Awesome. I'm glad it's clicking for you. And two, if you Google, how to solve FizzBuzz, there's tons of, blog posts and stuff out there with all sorts of different, efficient or creative solutions. And so it's kind of fun to read about that. So recursion. Okay. So this is interesting. So in recursion, recursion is hard. I'm just gonna say that recursion is hard. Because essentially what recursion is, for those of you who aren't familiar, recursion is when a function essentially calls itself. So you have a function, let's say a function, in this case we're going to have a function called isEven, and inside that function, the function is going to call isEven. So function in a function. And how can that possibly work? Well, it depends on how you write it. And we're gonna write a function that's gonna be able to work recursively to figure out whether a number is even or not. Is this chapter 3? Yeah, sorry, we did move to chapter 3. My bad. With the minimum, prior to the minimum program, we did move to chapter 3. Yep. Yeah, I should have mentioned that. We moved there before the last problem. Yeah. Yeah, I've talked to myself a time or two. Yep. Yeah. So what this question is asking is, it says, we've seen that the modulo, the remainder operator, can be used to test whether a number is even or odd by using modulo 2 to see whether it's divisible by 2, right? Because before when we tested whether something was even to see if when you divide it by 2, if the remainder is 0, then that number is even. And we use that for FizzBuzz too, right? We use 3 and 5 there. Here is another way to define whether a positive whole number is even or odd. 0 is even. 1 is odd, and for any other number n, its evenness is the same as n minus 2. Okay, see you, Noi. Yeah, thanks for joining. Have a great evening. So let's look at that again. 0 is even. 1 is odd. For any other number n, its evenness is the same as n minus 2. So let's think about what that means. So let's say we have 2, right? So if we say n is 2, its evenness is the same as n minus 2. So 2 minus 2 is 0, and 0 is even. Yeah, so that holds true, right? And 1 is odd. Okay, so let's say we have 3. So n equals 3, n minus 2 is 1, and 1 is odd, so 3 is odd. Yeah, that's true. So essentially what we're saying here, what this is saying is that that also holds true for any other number n. And if you kind of think about that a little bit, that does hold. So essentially we're going to write a function that proves it. Define a recursive function is even corresponding to this description. The function should accept a single parameter, a positive whole number, and return a Boolean. So it's going to take in like an integer, there we go. It's going to take in an integer and return a Boolean. So it's going to return true or false. And they want us to test it on 50 and 75, and then test how it behaves on -1. So first we're going to focus on the first 2 test cases, is 50 and 75. So we'll get it working for those, and then we'll figure out how to handle -1. Okay. So it gave us some freebies here for the very start. So we're going to say if num is equal to 0, then return true. And I know there's more efficient ways I could write this, but I want to be super explicit here because this is a really difficult mental challenge. So I'm just going to be super explicit about what we're doing at each step. Whoops, there we go. So if num is equal to 0, return true, because essentially we've been told that 0 is even and therefore true, and 1 is odd and therefore false. Okay. And so return true if it's 0. And then if it is else if num equals 1, return false. Okay, we were told those two things, and the only other thing we were told is that for any other number n, its evenness is the same as n minus 2. Okay, so we've said, oh, I don't know why that's, my alignment's weird there. No, fix that. Okay, we're going to put this inside a function anyway. So, so we've documented our first two freebies. Now we have to figure out how to say every other number. So, okay, else, our last thing inside of our if statement here, return, and we're going to say, here is where we're going to get recursive. Because here we want to say something about n minus 2, but let's say I put in 50, right? Subtracting 2, I mean, it's not going to return anything. I have nothing to compare it to. I have no comparison operator. So here, essentially what I'm going to do is I'm going to call my own function again and keep calling it until I get to something valid that I can return, either true or false. So essentially what this is going to do is it's going to walk through the if statement over and over again and keep calling is even over and over and over and over again until it can return either true or false. Okay, so our function here is going to be is even function, can't spell, function is even, and we're going to pass in our number n. It's going to put us into the if statement. It's going to walk through it. It's going to say, is it 0? Is it 1? If it's not, then call the function again. And actually, I'm going to pass in number instead of, I'm going to be more explicit here. Num minus 2. Yeah. Okay, so what is this going to do? Let's think about it. If I pass in 3, let's pass in 3, okay? Is 3 equal to 0? Nope. Is 3 equal to 1? Nope. Okay. Well, now I'm going to call the function again, but I'm going to pass in num minus 2, so 3 minus 2. Okay, so we're calling the function again, all right? And this time we're calling it on 3 minus 2, which is 1. So we do it again. Is num equal to 0? Nope. Is num equal to 1? Why, yes it is. And we can return false. Okay, so essentially what we're doing here is we're calling the function over and over again recursively and incrementing down by 2 each time until we reach either 0 or 1. Wild, huh? So let's leave it, let's not worry about that -1 for now. Let's just try it for our 50 and our 75. So we'll try it for 50 first. Let's see, I commented down, okay. Yep, so we got back true, right? We got back true because this kept checking whether or not whatever number we passed in was equal to 0 or 1, and if it wasn't, then it called the function again and just counted down by 2 and just kept looping. Essentially, this is like a loop. We're looping through again and again and again and again and again until we finally reach either 0 or 1, which tells us whether that number is true or false. Is the recursive function always added on the else? Well, for this particular use case, it would have to be, right? Because we want to do these two checks. We want to do these two num equals 0, num equals 1 checks first to determine whether we're ready to return our final value before saying, nope, we're not ready to return the final value yet. We're going to call it again. Don't try it with 16,000. Yeah. Why is the return on why is the return on line, I think on line 395? Well, I don't think we need that. I think we can, let's try it without and see if it still works. I think I was just kind of flowing there. Oh, nope, still doesn't work because we didn't return anything. So no, we need it. Return. And maybe somebody could tell me the logistics of that, but I think it's because if we didn't have that return, then if we didn't have that return on line 395, then it's not passing anything back out of the function so we can call it again. That's at least that's my semi-educated guess, is because we are essentially, in order to call the function again, we need to pass something out of this function. We need to pass out that we want to call is even again. We're taking it, we're removing it out of this function and essentially restarting. That's my semi-educated guess. Yeah. Don't try it with 16,000. Yeah. Or, yeah, 16,000. Yeah, because essentially what we're doing is, it's a pretty hefty recursive loop, right? We're recalling this function over and over and over again. Essentially, that would be 16,000. It would be 8,000 times, right? So that could be a little risky. But yeah, for smaller numbers like this, it's not going to be bad. So let's do it on 75. We'll make sure it works. Because now for 75, since 75 is odd, we should get an answer of false. So let's make sure. Yeah, false. Okay, that worked just fine. And that worked as expected, right? Because we passed in 75 and it kept checking it against these two numbers here. And if that wasn't true, it just kept recalling the function and subtracting 2 from our number each time. And so if you keep subtracting 2 from 75, eventually you're going to get 1 because you're going to have that 1 left over. Yeah. Now, let's see what happens if we put in, yep, that's a good summary. So the recursive function basically reduces by -2 until the number, because becomes either 0 or 1. Yeah, exactly. So because you know that if you take an odd number and you subtract 2 from it, keep subtracting 2 from it, eventually you're going to have essentially a remainder of 1, right? That's just the nature of odd numbers. Is if you keep subtracting 2 from it, any odd number is eventually going to reduce to 1. So that's what this is doing. When is the return? Well, it's being executed every single time we enter this else statement, because in order for the function to be recalled, it seems that the return is necessary. I think because it's breaking us out of this existing function, and it's breaking us out of the existing function and essentially allowing us to recall the same function again. Because remember, if we took this off, it didn't work at all. And I have to do a little bit of research on exactly why that is, but it seems to me that this return is essentially providing us with a break, getting us out of the existing function and recalling the same function over again from scratch and passing in the new number. After function is called. It's after. So we start with this function, right? We go through the if statements, boop, 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 boop. And then if it hits the else, then we say, okay, break us out of this, execution of the function, break us out of this execution of the function, and essentially start a new execution of the same function over again with a new passing in And we're passing in a brand new argument here. It's number minus 2. So we're starting over, starting fresh. So it's like it's more than just a loop. We're starting the function all over again with brand new arguments. It may be repeating the console log. Yeah, I'm not quite sure the exact mechanics of it. Yeah, I'm not sure. That'll be something I'll have to research exactly what the mechanics of that are. If it's calling the console log each time, if it's even hitting the console log each time, or if it's starting the function over or what. Yeah, it is interesting. I know. Yeah, and I think I did get this. I think I got this syntax actually from the Eloquent JavaScript text in there somewhere, telling me how to do that, but I don't remember for sure. Yeah, good question though. All right, so let's see what happens when we try to put in -1. What do you guys think? Any guesses on what might happen? And you can just kind of follow it through mentally. What might happen if we try to pass in -1 as our number? Any guesses? I guess the question is, so remember the goal here. Too much recursion. Oh, it doesn't like it. Oh gosh. Yeah, Chrome has some built-in protections on that kind of thing. Yeah, Chrome has some protections on that kind of thing. So it's trying to help you, but we're trying to learn. We don't want to be helped. No. Oh, nice. Thanks, Rascal. Very cool. Recursion.vercel.app. Yeah, give that a try. Yeah, that's awesome, Rascal. Thank you. But just thinking through this mentally, if we pass in -1 here, right? What's going to happen when we get down here? Yeah, it sounds like my hand, but it sounds like you might have tried it. Yeah, so essentially when we get down here to the bottom to our is even call, we're going to be passing in -3, right? Because -1 minus 2 is -3. So with that in mind, are we ever going to be able to get to 0? With the way this function is written right now, are we ever going to be able to get to 0 or 1 if we keep passing in larger and larger negative numbers? No, right? We're never going to get there. So let's run it and let's see what happens. We're just going to keep getting larger and larger negative numbers. So that's no good. Yeah, you're right, Jenks. Yep. Oh, jeepers. Uncaught range error. Maximum stack size exceeded. Yeah. That's just be saying like, nope, we got to stop. You're out of space. Yep. It said, nope, stack overflow. Yeah. Yes. Rather than just an online forum where you can get vague and confusing answers to your questions, Stack Overflow can actually happen. Good thing it's not inside a loop. Yep. Yep. So there's, yeah, Rascal. That's a good point. And some things can make much more sense visually than trying to think through them, just mentally. It's really nice if you can see stuff sometimes. So that's really appreciated. And we can check that out here in a minute after we solve our -1 problem. But yeah, probably the easiest, probably a quick way to solve that is to just basically filter out those types of inputs, right? So we should just say if a negative number is passed in, we're not even going to try to do any sort of calculations on it. We shouldn't try to do any sort of calculations on it. And we could correct it to a positive if we wanted. in my case, I mean, so what we could do is we could essentially just take in num, and if num is negative, we could multiply it by -1 and make it into a positive, or we could use, an absolute function on it. In my case, I was kind of a little bit passive aggressive about it, and I basically just said, hey, if num is greater than if num is greater than or equal to 0, then do all the stuff, do all the calculations, do all the stuff we just did, right? Just do all of this stuff. So if it's greater than or equal, then that's all good. But if it's negative, then just return negative and end the function. So don't even try. So if we do that and we pass in -1, yeah, then we just get the word negative. But yeah, you could absolutely be a very nice person. Like somebody mentioned earlier, you could be very nice and try to convert it. So we could say, else, well, nah, I'm not even gonna bother with that. Oop. Wow, hang on. Sorry. Battery's low. Yeah, we could do that. Yep, we could multiply it by -1. 1 second. I need to plug in my computer. I apologize. I thought I had it plugged in. 2 seconds. Yeah, thanks, Florence. If by stretch you mean stretch down to the floor to plug in the laptop cord, then absolutely. Yeah, no, this happened once before too. I honestly thought I had it plugged in this time, but I didn't. I have so my house is kind of old, and so I don't have very many 3-pronged outlets, just in general. And yes, I know about surge protectors and stuff like that, but the area where I'm sitting is right next to my fish tank, and my fish tank has like lights and filters, and so all of my plug space is occupied. The one 3-pronged outlet in the vicinity is very full. So, yeah. I gotta kind of ration my my plug space, but yeah. Okay, so let's look at that site that Rascal shared for Recursion. I'm gonna open it up here. Yeah. Okay. So sorry for the white screen. Let's enable. We're gonna enable dark mode. There we go. Hope that's better. So I love it when apps have a dark mode. That's really nice. Okay, so our global, let's see, we don't have any global variables here, so that's all good. We're going to grab the function. And, oh, I got to change my language here. Oh, got to do it in Python. Okay, any Python folks want to help me translate? Light attracts bugs. So it's weird in that you can't replace the whole thing, only the body. Oh, node. Yeah, of course. Duh. You're right. I didn't even read it. I was just looking, my eyes were just looking for JavaScript. Yep. Good call. All right. So body. Okay. Yeah, I see what you mean. It doesn't let me paste in. So I got to take the body. Okay. So I'm just going to grab the inner part. Oh, come on. Oh, come on. Okay. There we go. Okay. Let's take this inner part. So the name has to be FN. You can set the body and add parameters. Okay. So essentially, if I do this, we're not going to worry about the -1 situation. We're just going to look at this. Okay. Cool. And I pass in down here, right? So like say I pass in, we'll just pass in something easy real quick. We'll just pass in like 4. So then at the bottom you can call fn with the initial argument. Yeah. Okay. And then so my parameter is num, right? So this should theoretically work. We'll see. Let's try it. And I know this is very small. I wonder if I can zoom in. Sorry for folks that, there we go. Okay. Hopefully that's a little better. Okay, we'll run it. Is even, oh, I didn't, okay. FN, so I gotta say FN here. Yeah, got it. Yep, thanks Rascal, got it, cool. Yep, makes sense. That's interesting, it doesn't let you, okay, yeah, there we go. Oh, neat. Let's do it again. Yeah, that's rad. So we can step through it too. Yeah, okay. Let's start at the beginning here. We'll step through it. So we passed in 4. It starts running. Yeah, and so we get through this whole function, right? We get through this whole function, and then we get down here where it calls it again, right? So fn4 calls fn2 because we're passing in 4 minus 2. So fn4 calls fn2, and we're calling it again. fn2 runs, right? fn2, runs through this whole thing again, then calls fn0 because we're passing in 2 minus 0. fn0 starts running. Yeah, and then we're returning. So fn0 runs, it returns true. I see what's happening now. Okay, this is helpful. So we get down to 0, we hit that condition, so it says, okay, return true. So we're passing true back up the chain, back up our nested chain, passing it, returning it, up. And then fn4 returns true. So we pass it all the way down the stack. So when we go all the way down the stack, we dive all the way down to fn0, and then we have to pass that true all the way back up the stack until we finally get to our console log. That's wild. That's awesome. Yeah, this was very helpful. Thank you, Rascal. I'm glad we were able to visualize this. Yeah, wild. Very cool. My new favorite game. Yeah, because if we pass in something larger, like, I'm not going to step through this, but like 75. Yeah, look at that. Look at it go. Yeah, I'm sure if we had multiple parameters, it would get pretty wild. You start getting trees and stuff like that. And then, so it gets all the way down there to the bottom, right? And you can, now you see it. It's passing that true, or that false, all the way back up the stack. So it drills all the way down until it gets an answer. Then it passes it all the way up the stack. Oh, that's fun. Oh, I love it. Yeah, looks like it. Yep, you're right, Tim Tom. So we're returning true, yeah, all the way back up. And then that's what we're console logging. Yep. And Rascal says you can see some predefined functions in the templates dropdown if you didn't want to write your own. Okay, yeah, very nice. So if you just want to play with some recursion, Fibonacci, binomial, yeah. So I'll let you guys try those, but yeah, and I'll grab the link and I'll paste it one more time in chat here, so you guys can grab that again if you can't find Rascal's original comment. Thanks, Rascal. Very nice. And yeah, so back to our original code here. So, you can choose how you want to handle the -1. In my case, I decided to be a little bit sassy about it and just say if they try to pass in a negative number, I just had it return negative. But you could absolutely be a little nicer and multiply num by -1 and make it positive and then pass it in. That's up to you. Okay, so let's keep going. And this is actually the last problem. And so after we do this problem, I realized that I forgot in the minimum problem that we did up here, somebody gave me a couple of other suggestions that we could try for our if comparison here to make it even more compact, and I do want to try those. I forgot to do them earlier, so y'all don't let me forget to try them after we do the last problem. Because I said I would, so I definitely want to. Don't want to leave anybody hanging, if they're still here. Even if they're not, they can catch the VOD. Okay, so this last one, there's a lot of text, but what we're doing, the actual task that we're accomplishing, isn't too hard to wrap your head around. So, bean counting. You can get the nth character or letter from a string by writing string and then bracket n bracket. Now that should look a little bit familiar for those of you who've attended the array classes. This looks very similar to how we might get the array element that's at a certain index within an array, right? We would say like, array bracket 0 bracket to get the first item. So that looks very similar, and we can do something similar to that for strings. So the return value will be a string containing only one character, for example, B. The first character has position 0, just like an array, which causes the last one to be found at position string.length -1. Again, just like an array, right? Very similar. In other words, a 2-character string has length 2, and its characters have positions or indexes 0 and 1. Write a function count B's that takes a string as its only argument and returns a number that indicates how many uppercase B characters there are in the string. Next, write a function called countCar that behaves like count B's, except it takes a second argument that indicates the character that is to be counted. So rather than counting only uppercase B characters, rewrite count B's to make use of this new function. Okay. And then it gives us some test cases to try here. So the first one is count B's. We want to count BBC. Okay, and then the second one we're going to count Kakerlak. I don't know if that's a word. And we're going to count the K's in Kakerlak. So let's do the first one first. So we want to pass in BBC, and essentially the answer should be 2 because there's 2 uppercase B's in BBC. So let's think about how we can do that. So we've been given a little bit of a clue here. And essentially what that says is that if we take, if we pass in a string of any kind, we can essentially say string, we can essentially say string, bracket I to get a single letter at whatever position we say I is. So if I have the word, let's say if I have the word cookie, I could pass in string 0 and get back on the word cookie. I could pass in string 0 and get back C, right? That's the first element in that string. So let's make our function. Let's say count B's. And we're going to pass in, we can just call it str for string. So we'll say function count B's. Function count B's. And we're going to pass in a string, and we're going to call it str for string. Okay? And we know we want to say something with like str bracket, right? To get essentially one letter at a time and then compare it against to see whether it's B or not, right? So essentially what we want to do is we want to loop through or increment through the entire string, looking at every single letter and comparing it to see whether or not it is and uppercase B. Okay, so what could be a way that we could iterate through the entire string? What's a way that we already know to iterate through anything, really? Mm-hmm. Yeah. Yep. Yep. In this case, we're going to go ahead and just use a for loop because we want to make specific use of the of this option right here, where we can look at a single string index at a time. But yeah, for each is definitely an option as well. In this case, we're going to go ahead and use a for loop. First thing we're going to do is we're going to declare a counter. So we're going to say let count, and all this is going to do is it's just going to be a bucket where we're going to keep track of the number of B's in our word. So we need to count that independently of the string that we're looping through, right? So because the string could have no B's at all, so this would remain 0 even as our loop is counting upward. So we're going to just declare this count really quickly. We're going to keep that at 0, and then we're going to set up a for loop, and we're going to say for let I equals 0. So because remember our string, like it's set up here that essentially the first item in our string has position 0, right? And the last one is going to be found at position string.length -1. Okay, so we're going to start I at 0, and we're going to say for an I is going to be less than or equal to, what's my I, where do I want my I to stop? If I want to loop through all of the elements in my string and the first one is at position 0, yeah, yep, you guys are on the right path, absolutely. Yes, the last letter, yep, and the last letter, the first character has position 0, which causes the last character to be found at position string.length -1, right? So yes, absolutely. So we're going to say string.length -1. Yeah. And then we're just going to do standard for loop increment. So we're going to say I++. And inside that for loop then is when we're going to do our actual comparison. I'm going to change this here. Say boop, doop, doop, doop. There we go. Yep, you guys are all on the right track. Absolutely. Yeah. So now essentially all we have to do is check to see whether the given letter that we are on is equal to B. So we're going to say just if string at position I, so whatever index we're at, whether that's 1 or 2 or 3 or 4 or 5, the letter at that position, we're testing to see whether that is equal to a capital B. Oops. Yeah, go ahead, Mohammed. Yeah, go ahead, ask. No problem. And if that's true, then we're going to, if it is equal to a capital B, then we want to increment our counter up by 1. Yep. And then if it's not true, then we don't want to do anything at all. We don't want to increment our counter, so we don't need to put any other conditions on this in this if statement. If it's equal to a capital B, we're going to increment our counter. If it's not, then we're just going to go into the next iteration of the loop. And the question was, should the condition have a less than instead? Well, so we were explicitly told, and I guess I'm really just trying to use the, what we're given in the instructions. And so since the last letter is found at string.length -1, if we did just a less than, then we would stop. Our loop would stop prior to the last letter in our string. We want to go all the way up to equal to the last letter in the string, right? So I could have just done less than string.length, right? And that's actually what I did in my version. But I'm using exactly what we were told in the text for the problem. So in that case, if we're going to position string.length -1, we want to include that position in our comparison. I hope that helps. Because if you think about it, if we had, let's say we pass in the word BBC, right? So let's just talk through that loop. So we start at 0, and we'll take the equals off of there. So we start at 0, right? We go through the loop. We increment by 1. So at position 0 is B. We go through the loop. We increment by 1. Now I'm on to the second B, and I'm at position 1. And if not explicitly stated, and so now my I is equal to 1, and my string.length is equal to 2. So we've almost hit the length now. And now if I iterate one more time, I is now equal to 2, and I is equal to 2 here. And we've essentially said if 2 is less than 2, then we end the loop. So we don't get that last letter included in our loop. Right? Yeah. If not explicitly stated, how do we know when to use length -1 or just dot length? In this case, yeah, I mean, I'll be honest, like for my version of this, I used I less than string.length. But I am using string.length -1 because the problem specifically states that we should. I think when you're, it's just important to just know that if you're going through an array and you're talking about the position of items in that array, then you just have to remember that it's going to start at 0, and the last item in the array is going to be located at 1 less than the actual length of that array. I think it's just important to know the difference. I think in this case, it doesn't matter all that much. But it is important to remember that when you're talking about an array, the last item in the array is going to be at 1 less than the length of the array. It's just an important concept to know. So yeah, I can't give you a strict, like, this is when you use, length -1 versus this is when you use length. I think it's just important to know in arrays in general what that length versus index position means. Yeah, and in this case, string is an array of characters, right? Yes, it is. And I think at this point in Eloquent JavaScript, it hasn't really defined arrays yet, but essentially that's what we're doing. We're doing an array operation on a string. Yeah, with arrays, you want to use 0. Yes, because in arrays, the way arrays are defined, if I have an array of, let's just say, like, if I have an array of numbers, 34, 56, I don't know, random numbers, whatever. The position of this first number is actually 0. And that's just the way arrays work. They start at 0, always, no exceptions. So the index of this first item is 0. The index of the second one is 1. Third is 2. And the fourth is 3. I know that's hard to get your brain around, but just think about the index always starts at 0. So the length of this array is 4, right? There's 4 items in it, but the index of the last one is actually 3. Otherwise, you'll miss out on the first element. Yes. Yeah, if we tried to start at 1 here, we'd miss out on the first letter. Yep. Yep. So let's run it. Let's see what we get. And also too, I don't have a return statement in here just yet, so I'm going to need to put my return statement in. After we finish the loop, we're going to, after we're done, completely done with the loop, we're going to return the final count of our capital B's. Okay. And let's see, do I have a console log in here? I do. Yeah. Okay. So we'll run this. Yep. So that got us the answer we expected. Now, this just for funsies. Let's say we forgot and we started at 1. We forgot that arrays start at 0 and we started at 1. So let's see what that does. Yeah, so now instead of 2, we get 1 because just like Muhammad, just like you said, we started at 1, so we entirely missed out on that first B. Yeah, it didn't even check it at all. Yep, because we didn't count what was at index 0 in our array. Yep. So let's fix that back. So, and we can try other words too. So we could try, let's do beach ball. We'll say, and I'm going to do it like this: beach ball, lowercase b, uppercase b, like camel case. Yeah, and just as expected, we get 1 because there's only one capital B in the whole string. Yep. So questions on this first version before we make the second version? I'm going to take another hydrate here. Oh, hey, thanks for tuning in, Caitlin. Yeah. Hope you enjoy your dinner. Yeah, I know we've been going for a little while, so I'm sure you're probably hungry. Oh, hey, don't worry, Claude. It's okay. You'll be able to catch the VOD, so you'll be able to catch up on everything that you missed so far. Yeah, no problem at all. The VODs are going to be available on my channel. Okay. So hearing no questions, we'll go ahead and we'll move on to the second iteration of this, but feel free to ask at any point. So I know arrays are weird and confusing, but hopefully you're starting to pick up a little bit on how they work and how we can treat strings kind of similar to arrays. Okay, so let's look at the section function that they want us to write. So I'm going to move this up a little bit. Here we go. So we want to write a second function that's called count car, and we want to be able to pass in a word and then also pass in essentially the thing that we want to compare that to. So the character that we want to count. In this case, it's a lowercase k, but it really could be anything, right? It needs to be dynamic. So really, this isn't going to be too much of a stretch compared to what we did last time. So I'm going to move this down. And essentially, we are just going to say function count car. And we're going to pass in, again, we're going to pass in the string. And then this time we're also going to pass in a character that we want to check. So I'm going to call it the check car. Right? And again, we're going to say essentially the same thing. We can just say let our counter. So the thing that's counting the number of characters of interest, that's going to hold that there. And then we're going to say for, again, same operation, let I equals 0. We're starting at the 0 index in the array, and we're iterating through it for the where I is less than or equal to the last value in the array, which is going to be string length minus 1. And we're iterating I as we go. Okay, so inside here, essentially the only difference that we're going to have from our previous is instead of comparing it to a hard-coded B, we're just going to compare it to our check car, whatever that is. So in this case, I'm going to write it out first as a standard if statement, and then we can make this a little bit more compact. So we can say string I and essentially just, strict equal to check car, and everything else is the same. So if string I is equal to a check car, then we iterate our counter. Else, nothing else, and return our count. Okay, so you might notice that what we're doing in this if statement is really only one thing, right? We're saying if the item at this particular index is equal to our check character, then add 1 to our counter, otherwise do nothing. So there's got to be maybe a slightly more compact way to write this statement, right? Rather than using 3 full lines to really do one thing, we could condense this down to essentially just one line and make our function a lot smaller. So as I did, you might think, well, hey, that sounds a lot like a ternary operator, right? We could maybe say string I is equal to check car, and then if that's true, get this. If that's true, then increment our counter by 1, else do nothing, right? And so we could say like else null, where null means don't do anything. There's nothing there. So we could say that. Or we can make it even more complex, or even more complex and compact, by essentially saying, since we don't have an else statement at all, we can just do this. And that's like a super shorthand way of saying, hey, if this statement is true, then do this thing, else don't do anything. There's no else statement at all. So that's an even simpler one-line if statement. Don't expect you to remember that. I just think it's kind of cool. So if you ever want to do a very simple if statement that just has one action if the item is true and there's no else, then you can do this. Use the double and it will it'll perform whatever action is over here. Yeah, and this was in the reading. It's one of those things you might not catch immediately because it's not strictly necessary to do what you're trying to do, but it's a pretty slick way of simplifying an if statement even more. Yeah, and that's totally fine. I was confused too, but the more I'm starting to try to use them, you read it and you're just like, what? But you can think of areas when they might be applicable, and like in this case, it's the perfect application, right? Because we have an if statement, it's super simple, there's no else, and it seems like a little bit of overkill to write it out fully like that. So we can use this shorthand and try this shorthand, and hey, it works. Yeah, so let's run it again, and we'll make sure that it's gonna do what we expect. So actually, we haven't even run it once, so I'm living dangerously here. Log this, comment that out too. So we're gonna run Kakerlak into this, and we should expect to get 4 because we're passing in Kakerlak and K. Okay, so let's see what we get. Clear the console and run. Yep, we got 4. Hooray. Yeah, just as expected, right? So we passed in Kakerlak, and it looped through the whole length of the string. And for each index I in our string, it checked it and it said, hey, this statement is true, so I'm going to do this action. And for every item that was not K, so like if we get to our index 1 here, it would say, hey, that's an A, that's not true, so I'm not going to do this action. And then at the very end, after our for loop was over, it returned our total count that we had added up to so far. Yep. So yeah, we managed to take our fairly long initial function and condensed it down by several lines, and it looks a lot shorter now and more compact. So when you start getting really long functions, it's cool if you can, find little shorthand ways to make them slightly shorter and easier to parse. But okay, any questions here? Yeah, no problem. Okay. Well, that brings us to the end. Oh yeah, no problem. Yeah, and two, like these alternatives, it's not that I just like knew these right off the bat. A lot of times what I'll do is I will write it out in like longhand. I'll do the full if, I'll do the full else, I'll write it out in the classical if else statement, format, kind of like we did for the first one. I'll, write it out longhand. And then after I've written it out, I might think, hey, just by looking at it, I might say, there's got to be a way I can make this simpler. Like this looks kind of wonky, right? And so just by looking at it, then that makes me want to think about what alternatives I might be able to use. And so, for example, I'll just walk you through my thought process, like on this one. So I wrote this out longhand, and then I decided I wanted to do something different for this one down here. So what I initially did is I used what I knew, which was the ternary operator, right? I did this, and I said, okay, so it's true, I want to do that. And then I had my else statement here, and I didn't know what to put here. I tried putting nothing. I tried leaving this blank, and boy, oh boy, it didn't like that. Because you got to put something here in the ternary operator. And so I Googled around, and it said, well, you can put null there. And I was like, okay, fine. But it's still unnecessary, right? You don't, like, there's no else. There's legitimately no else. And so I went on Stack Overflow, and I saw somebody ask the same question, and they said they got tired of putting null in their ternary operators. And then the answers there then reminded me of what was in the reading of saying that, yeah, if you've got an if statement that doesn't have a null at all, you can use the double and operator to essentially just execute the true statement with no else. So it's an iterative process, right? We start out with the most complex thing because that's what we know, just instinctively. We know that's going to happen, and it helps us visualize the logic. And then you can go back and refine it even more and make it better and try things. Yeah, I usually go with having the if condition and expression on a single line and having the curly braces off. If I'm looking to refine it like this. Yep. And if that's what fits your fancy and makes sense to you, and I mean, yeah, it brings it down to a one-line statement, right? So if that's what works for you, then yeah, that's absolutely a way to do it. And that may be what, a lot of us end up doing if because it keeps with the standard format, and it also brings it down to one line. In this, when we're doing these kinds of exercises, since we're not really like doing anything for, an actual project, I'm trying to, I try to kind of experiment with the different options we've been given so that I can find something that really clicks for me, and just practice all the different alternatives. So that way, at the very least, even if I don't use them, in my day-to-day work, if I see one in the wild, I'll know what it is, and I won't just be like, what is that even doing? I'll know at least what it's supposed to be doing, and then maybe how it operates. But yeah, that's a good point, Rascal. You know, you tend to find something that makes sense for you instinctively, is fairly efficient, and you know, you just know how it works, and so you can write it out really quickly. So yeah, good point there. But I would suggest for now, for us, you know, experiment with the different alternatives, so at the very least, even if you don't end up using them, you'll know how to recognize them and you'll know what they do. Yeah. When you see them on Code Wars, you'll know what they are. Yep. Absolutely. Yep. Okay, so yeah, so that essentially takes care of this one. We could put in another word here too. We could say like, we'd say gazelle, let's say gazelle, and we could put in, you know, L. Actually, I'm going to have a lowercase and a capital L here. So we've got Gazel, uppercase L, E, and I'm passing in lowercase l for my validation item. So we should get 1 here. That font treats uppercase really oddly. Stick him in your Yankees. Yeah, absolutely. Stick him in your Yankees. Good call. Yep, but we did get 1 back because we evaluated for lowercase l. So, yep, that behaves exactly as expected. And if I run this again, I should get 2. Yes. All right. So that function seems to be working. Any last questions here? Before we're going to go back up and we're going to revisit our minimum function. We're going to try some of the alternatives that were proposed earlier, and you know, have a little fun with streamlining our if statements and try some various options. Okay. And I didn't comment this one out either. Whoopsie. Okay, where's my minimum function? Up here. Here it is. Yeah, so revisiting our minimum function, and for those of you who who weren't around for the first time that we ran this, we essentially started out by, you know, thinking about, we started about thinking about like, hey, look, this is a pretty simple operation that we're being asked to perform, right? We said, logically, I'm going to pass in 2 numbers, num1 and num2, and it's asking me to find the minimum of both of those, right? So if num1 is less than num2, I want to return num1 because it's the minimum. But if that's not true, then the only other 2 possible cases are that, oops, I'm sorry, my laptop fan is burning out. Ah, I'm sorry if that's loud. 1 second. Gotta go on mute for 1. Well, thank you. Okay, well that's good to hear then, because the Twitch noise cancellation must be very good then, because it's very loud on my end. My laptop fan is dying, and it occasionally just likes to pop off and, you know, be super loud and annoying. I'm gonna get it fixed, but I haven't yet. So good. Twitch is better than I thought. Okay. Anyway, so what we said is essentially that if num1 is less than num2, we want to return num1, right? In the only other 2 possible cases Or, yeah, good old percussive maintenance until then. Yeah, literally, I have to smack it until it stops doing that. So that's why I went on mute, so you didn't have to hear that. But yeah, literally smacking it. So if num2 is greater than num1, then we return num2, right? And if they're equal, then it doesn't matter which one we return. We could return num1 or num2, and it wouldn't matter. Next time, don't mute. I don't think you want to hear me thumping it as loud, as hard as I can. Channel points for laptop thump. Yeah. Luckily, it's solid state, so it doesn't matter. But I'm not going to be, damaging my hard drive. Yeah, so anyway, we refined this function to essentially be a ternary operator because it was a pretty good candidate for it. Really just if num1 is less than num2, return num1, else return num2. So pretty simple. But somebody mentioned, I'm going to scroll up until I find it. There were additional alternatives mentioned that I just wanted to try. And, if you're, if you want to tap out, that's totally fine. You don't have to stick around. But we're just going to try a couple of these other options here because I said I would. So I'm going up. I hope I can still access them in the chat. Scrolling up. I think I'm almost there. Oh, yeah, okay. So Chris mentioned, yeah, I found it. And luckily I found it. It was almost off the edge of the chat where I can't scroll up to it anymore, but I caught it just in time. So the couple suggestions were return, let's see. Return true, question mark, num1. Okay, so yeah, I think it was return true, question mark. Oops, I have two returns, my bad. Get rid of that. Return true, question mark, num1, colon, num2. I don't think, I'm not sure if that's going to work. Because we didn't do the comparison. Oh, yeah. Hey, good to see you. Yep. Thanks for joining. Yeah, I'm not sure that's going to work because we aren't actually doing we're not doing the comparison there. Yeah, I don't think that's going to be, oh, yeah. Yeah, thanks for joining, Hippie. Yep. Yeah, I would just return num1. So because at some point we do have to do the actual comparison. So yeah, we need the thing that the operation that we're trying to accomplish in there somewhere. So I do think that this is, the original num1 less than num2. But I mean, bonus points if somebody can think of a way to simplify this. I'm sure somebody could get it down to like 2 words, right? There's going to be somebody out there that could get it down even more. But I do think this is a decent way to do it. Return, yeah, and you're right, Tim Tom. In this case, the question mentions the standard function math.min, and we could absolutely use that. The challenge here, I was kind of trying to challenge to say, how can we do that without using the math.min function? Yeah, we could, and yes, we could do it in arrow function as well. We could. No, that's totally fine. Don't worry about it. It's kind of ambiguous in the way it's worded. It was kind of my choice to say, can we do it without using the math.min? So yeah, let's make it into an arrow function. I'm probably going to screw this up. But essentially what we're just going to say is we can say like const min equals, feel free to correct my syntax here. And I believe the return is implied, right? So we don't need the return. Oh, whoa, what did I do? What did I do? I didn't inspect. My bad. Sorry. And we're passing in num1, num2, and we do equals fat arrow here. And then we don't need the curly braces because it's a single line, right? So is that right? Yes? I think. I'll give you all a second to look at it. I can always try to run it and see if we get an error. This is good practice for arrow functions. And I believe the return is implied, so we'll see if we get undefined or not. Yep, no curly's needed. Yeah, awesome. Let's run it. See what we get. Yeah, thanks for the checks, guys. Awesome. Thanks, Lee. Thanks, Silent Spy. Thank you. Yes. Yeah, we got it. We got it. All right. First try. Yes. Awesome. And I forget where that 2 comes from, down somewhere down below, but I forgot to comment something out somewhere. Yeah. Exactly. Now you can change all the variables to single character, remove all the spaces, minimum characters, minimum readability. Exactly, Rascal. Yes. Yep. Minimum characters, minimum readability. Yeah. And that's always the trade-off, right? It's like some people are like, minimize your space usage at all costs, but the cost there is often very high in terms of comprehension. So I prefer to have longer variable names, and maybe sacrifice some space, but. Oh, no, you're good. A new coding challenge has emerged. I mean, yeah, you could absolutely do that. You could do this. You could be like const m n1 n2. You could do this and be super, super compact about it. But if you were just coming in and looking at this with no, ditch the just do this. Yeah. Would that work? You try it. Oh, I guess it'd just be making it anonymous, right? Like this. Nope, still doesn't like it. Oh, because we're, right, like this. Would I have to put the console log around that? Would I have to put the console log around my anonymous function? We're just getting wild here. None of this is required. We're just doing it. Yeah, it still worked. Woohoo! Look at that. Yeah, this is too far. I have exceeded Rascal's bounds of acceptability. Yeah. Yeah, exactly. You won't find a single project manager that'll accept this into the code base, and rightly so, because look at this. What is even happening here? If you came in, if you didn't have any of the question text, yeah, exactly. If you didn't have any of this question here, if you just came in and you saw this, you could probably get it just by, passing some arguments into it and seeing what it's doing, but this tells you nothing, right? So you got to be, be practical about it, right? Be reasonable, be practical. Type a little bit more and make it a lot more readable. So, yeah. We're just getting wild. We're up here getting wild. Yep. All right. And I've made like a bajillion changes and haven't been saving, so I'm going to save this too. Yeah. Yep, exactly. Type more, remember, and think less. Yep. Yeah, a little bit more effort now leads to a lot less effort later. And also, comment stuff too. Use the comments and comment what your code is doing. you might be like, oh, I'll remember. And no, you will not. You'll come back and you'll be like, what did I even write? Yeah. Okay, well, that finishes up the Eloquent JavaScript that we had to do. So, I don't want to like this is outside my normal stream schedule, and I don't mind streaming at all. I'm the one that set this up, but also too, I know that this was unplanned for most of you guys, so I don't want to keep you. But I do want to make sure. Does anybody have any additional questions on this before we go ahead and end for the day? And I'm thinking too, feel free to ask your questions. And I'm thinking for Sunday, I do want to do kind of a fun little project. I still want to build the Wordle game. I know we all have a lot of questions on arrays and that kind of thing. But I think we're going to probably be covering arrays for a while. So I do want to do something a little bit more fun on Sunday. And, go back to seeing how we can apply these concepts and build something that's real, versus just doing, we're all doing code wars, we're doing a bunch of exercises, but let's build something that puts this stuff into practice and gives us a real outcome that's fun, that we can use, that's an actual project. So that's my opinion on it anyway. But yeah, feel free to ask any questions here before we end. Hey, no problem, Tim Tom. Yeah. And I hope to see you all back here on Sunday. We're gonna have a little bit of fun, and we're gonna build Wordle. And for those of you who might not know what that is, I'll just show you real quick. Wordle. So it's a game where you, no problem, Mohammed. You have to you have 6 tries to guess a word. And as you play, it tells you whether or not your guesses are correct. So in this case, I guess the word plate, the letters P and L are not in the word, and the letter A is in the word, but I didn't put it in the right place. And the letters T and E are in the word, and since they're green, because I put them in the right place. So as you continue guessing, it crosses the letters off on the keyboard down here as you guess them. And it also marks them with the appropriate color, and it marks them up here as well. So, and so as we continue to guess, you'll see that, it goes to the next row, right? And so this might look a little bit familiar, this grid, right? Yeah, so yeah, try it. And we're going to build this. We're going to build this actual game on Sunday with all this functionality, with the keyboard turning colors. And, oh, good, Ray Anthony. I'm glad it was helpful. I know this stuff is tough, and especially the Eloquent JavaScript. It's kind of on a different level. But, the more we do this and the more we do it together, the better we'll get, the faster we'll get, the more you'll get used to thinking creatively, right? Yeah, so I'm glad this was helpful today, and I hope to see you on Sunday, and if not Sunday, then maybe next Wednesday. We'll probably be doing another homework review on Wednesday. But hey, thanks for coming, Lee. Yeah, we're gonna have a lot of fun on Sunday. So yeah, and you're right, Ro. So essentially, what it's telling us is that it starts with an S, ends with a TE. Has an A in there. So really the only other option is that A must be the second letter, right? It's not the third letter because it's yellow. And so we have S-A, S-A something T-E. Imaginary channel points for yep. I think Skillet's got it. I think Skillet has got it. And ironic considering your name. Yep. Yeah. That's a good first time chat. That's a good first time chat, Meg Extra. If you're gonna chat for the first time, you might as well get the Wordle right. Impromptu Twitch plays Wordle session. Yeah. What better way to end a stream, am I right? So let's try it. Hey! Impressive. Yeah. Yeah. And a new follower. Awesome. Yeah, so we got it. We got it third try. Go us. Yes. All right. I would say there's no better way to end a stream than winning on the third try at Wordle, right? That doesn't happen all that often. Way to go, Meg. Yeah. And way to go, Skillet, too. Good job, Skillet and Meg. Third try. Third try Leon voice. Yes, third try. With except with Wordle, like that's really good. So we're all really smart and we deserve applause and claps on the back. So good job, guys. And so this is what we're going to be building on Sunday. So I think I have it on my schedule. It's like 6:30 Eastern time on Sunday. So hope to see you guys all there. And yeah, have a great evening. I think this is the best possible way to end it. So I will talk to you guys in a couple of days. And feel free to message me on Discord and follow me on Twitter. And yeah, catch the VOD if you missed any part of this. So talk to you later, guys. Have a great Saturday. All right. Bye-bye.